it sends its passengers into free-falling weightlessness.
As you push over, if you push over at the same accelerated rate as gravity is pulling you down, you get a sense of weightlessness. Well, that only lasts 30 or 40 seconds per parabola, because obviously you got to pull the nose of the airplane back up, or you ruin your whole day. You don't get a feeling of falling. It doesn't feel like you're falling. It feels as though you're inside a room or a vehicle, and there is no gravity. Somebody has suddenly hit this anti-gravity switch, and you and everything around you begin to float. That's the feeling that you have.
In space, that feeling lasts for more than 30 seconds. Because up here, the shuttle, traveling at 28,000 kilometers per hour, is carefully balancing between the force of gravity that is trying to pull it back to Earth and the centrifugal force working against gravity. The shuttle is actually falling around the face of the Earth, and the continuous free fall creates the sensation of weightlessness for those inside. The logic is indisputable, but it doesn't make it any easier to live with. In the payload processing facility, a massive, strong back crane moves cargo in and out of the shuttle's payload bay. Roughly the size of a great blue whale, the bay can be reconfigured for any array of mission hardware. This payload can be anything from a military satellite to a highly complicated scientific laboratory. Some payload is controlled from the shuttle, some from the ground through sophisticated telemetry.
Here at Space Lab Mission Operations Control.
Each breakaway unit represents years of work on Earth, and payload specialists on board train for months to execute the work of teams anxiously monitoring their projects in space.
And we're now seeing the highly magnified image from the Wisconsin instrument as it is trained on this Galaxy NGC 1068.
GPS CDR, go ahead, on left keyboard.
To guard the delicate cargo against contamination, strict cleanroom conditions are enforced throughout the payload facility.
50. And execute.
Below deck, reams of wires and sensors are checked, and then checked again, and again.
DC power 2 switch on.
When it comes out of the orbiter processing facility, all the work's been completed, all the tests have been passed, all the data's been reviewed. Everyone is satisfied and is asked to say that, at least to themselves and to their immediate supervision. Are you ready? Is your system ready? The only thing that you sit there and think is, was there something that someone, or is there something even that I missed along the way that somehow or other we could have caught? You can't help as a human being not to have that nagging feeling that, have you ever done enough?
The shuttle is now ready for its final configuration in the Vehicle Assembly Building, a mammoth structure 43 stories high that once housed its predecessor, the Saturn V. Here, it is raised upright. The orbiter is, after all, a rocket, and it can only take off while standing on its tail. Once upright, the orbiter is carefully mated to its massive external fuel tank. The process is so delicate that it takes 36 hours. The tank will hold 500,000 gallons of highly explosive fuel. The slightest snag would mean disaster. Flanking the external tank are two solid rocket boosters, the SRBs, 45-meter-long tubes of solid, supercharged fuel, encased in steel. SRBs have been tested and engineered to provide 85% of the force required to lift the shuttle off the pad. They are the most powerful rockets ever built. The slowest part of the orbiter's 5 million kilometer journey is the first 5 kilometers. At 1.5 kilometers an hour, the aptly named Crawler is the largest and possibly the slowest vehicle in the world. Weighing in at nearly 3 million kilograms, the Crawler tilts, shimmies and pivots to keep the orbiter upright on a mobile launch pad, and then using laser guidance, sets down its burden within a 1/16 of a centimeter. A clumsy, lumbering beast that can stop on a sixpence. Once at the pad, the shuttle's external tank is filled with cryogenic fuels. It is now a volatile rocket in which 7 people will ride. In the hours before the launch, the pad is cleared of all but the most essential personnel. Among them, members of the ICE team.
We've only got 2 hours to look at every square inch on this vehicle and pronounce it ready for launch. We are well aware that there's over 2 million pounds of solid rocket fuel in the boosters and over 500,000 gallons of cryogenic fuel in the external tanks. So it is a hazardous operation. There is potential for major problems there should anything ever occur. So all the team members are volunteers.
After all the planning and designing and building and hoping for the best, the success of the journey finally comes down to the people who will make the trip.
We're at the 195-foot level of the tower. Crew module's right here. The external tank is not more than 20 feet to this side, and there's a solid rocket booster that's loaded and ready to go that's right next to it. So we're right in the middle of it. You're one of a dozen people that you're out here, and everybody else is 4 miles away.
In the firing room, 300 technicians and engineers prepare to launch as systems power up.
They're not going to get much below minus 100 degrees Fahrenheit, but engine 2, engine 1 might be down to minus 200. I guess it's because of orientation.
TLS, TLS, go. Yeah, 534, pick up by the clock. Okay, TLS. There you go. Okay, we got you now. Here while you're ready for a count.
At this point, you're kind of numb to the whole thing, I think. You're just excited a bit and looking forward to getting in and strapped in and settled down. It's a bit uncomfortable like this. Kind of laying on some valves in the back of the suit. But it's not too bad for the first hour and a half or 2. As you approach a little after that, you start getting a little uncomfortable with sometimes back pain. So the quickest way to get comfortable is to launch, you know.
All right, well, I'm trying to fend off the dogs. All right.
There is no actual button that someone pushes. It's operating the keyboard to set up the ground launch sequencer to take us through that final launch phase and launch the vehicle.
90, 96, 99.
In this pyramid of reaching the final go for launch, everyone is polled formally over a network where they have to indicate that they are really go to proceed, and that makes the person really think about it.